So, good morning to you all. Hopefully, you all can hear me well. My name is André Pinto, and I'm today here presenting my PhD topic that is a control strategy for underwater vehicle manipulator system. My supervisor are Professor Nuno Cruz, Professor Bruno Ferreira, and Professor Ian Soares. So, the idea is to add a manipulator to underwater vehicle and enable it to have capacity to grasp an object. So, not specifically this one, this is just an example. So why this is important? Normally nowadays in oil and gas, underwater oil and gas inspection are the tasks of intervention are still done in the teleoperation mode, or that has problems. Normally you need to an operator, train operator. You also are dependent on the performance of the system is dependent on the tiredness of the operator, and also you need real-time connection between the operator and the vehicle. So you have to have a tether and a support vessel at the surface to have always contact communication with the vehicle. So this adds costs to the infrastructure. Also, when you are in teleoperation, normally to compensate to when you move the arm underwater, you also move, the vehicle will move in the contrary direction due to Newton's third law. So one way to the normal in teleoperations to deal with this is to have the mass of the vehicle very large compared to the arm. Or if you try to minimize the difference so you can reduce the size of the infrastructure, you have coupling effects. So now you have another problem that is how we deal with that. So here we can try to remain stationary with the vehicle and just move the arm or control both systems. So having this all in mind, I have defined some objects for this PhD. So the first one is to express the dynamic coupling between the two systems. The second one is to compare this to control approach that I also have referred. From this, we can, in the couple one, we can extend it further. So, can the vehicle increase the degrees of freedom, for example, of the manipulator, and have better capabilities to grasp an object? That's another object that we will try to answer, and test it along the real system and develop and validate the performance of the system. So, regarding the scheduling, now I'm here on the part of the typical scenario simulator, so I'm trying to read the state of the art to see what has been done in these years, what have been done already in this topic, and define where is my space to work and what will be my objects that I intend to grasp, what will be the duplicate perturbations, and I'm also checking right now the simulators that I will be using to demonstrate my work. So these are the main parts. The other parts I want to reference is the scientific papers. I already have the three more or less the topics defined. One will be when I have the whole systems in simulation working, so we'll end right about here. The second one will be when I have the perception scene. So besides the fact that to grasp the object, we have to first identify where it is. So this is also a challenge underwater because depending on you are on the depth, you can have variable distortion effects, and it's difficult to encounter and to track the object. So that will be another part of my publication, and the final one will be with all the system working. So just a quick overview of state of the art. So here we can see a roadmap of the work done in underwater manipulation that starts in 95 and goes to 21. So basically, during this project there are three main categories: the fully operated, teleoperated, that is just the operator that performs all the tasks; the shared memory, that when the vehicle provides some feedback or the manipulator and has some enable features like, for example, keep them at certain depth, keep certain attitude and stuff like that. And the last one is fully autonomous, that what we intended, and this was the last part that we are arriving today, where already have been demonstrated some coordinative grasping of the objects in the TwinBot project. However, this has been done in the artificial made objects, so proposally built to be grasped, so there is still room for improvement, I think. So regarding this roadmap, also were two main universities involved, so the Girona and Geneva. So these are the people that are actively working in these topics. So just to give you an idea of the parts that I am in the PhD, so the typical objects that I define more or less it will be working on will be regarding to tasks. So pick and place and maintenance intervention. In a pick and place there are some objects that we want to pick. You can start by making artificial objects. especially made to be manipulated, so it's easier to grasp it. For example, a beacon, so you can drop a beacon in a certain position, so you can return it later, for example. Or you can have not man-made, so specimens like an animal or rock that it's a geometry that we don't previously know. So that's the challenge, and I think is where there is room for improvement. Also, they made the tool to grasp an object to perform an operation. It's also some kind of improvement that can be done here. Also, the general perturbations that are encountered are currents and waves near the surface at very small depths. Also, regarding the simulators, I did just some research about it because I will need one for my PhD for my demonstration. So the idea is to generally we have an software architecture and there at the lab, and the idea is to have a simulator also at the other end, so you can try the software at the simulator or at the vehicle and just test it independently. So it's better at a better field at the simulation before testing on a real vehicle. So this is just a comparison. Probably will be something related to ROS and follow the standards of the industry. So that's what I'm seeing here, and the plugins for the sensors and environments that I require, so I can better select what I will use. Regarding the curriculum plan, already made the first one, the research topic and methodology. The options are already matched with the what I intend to publish on the three papers. So the control in the image part, seminars will end with the report today, and the thesis planning and scheduling. Lastly, I just have the graphical abstract to resume all of this. So basically on the left there are all the things I talk about. And on the right you have some kind of image. So the idea is to, if you can have a vehicle that has manipulator capabilities to grasp an object, that will be valid and you can reach more valuable stuff. But before that, we can generally need to know where is the vehicle, where is the object to track. So there is the vehicle with the periscope, and then when you try to grab, the object can run away, or the environment perturbations can push us away. And also, when we move the arm, the vehicle also has the dynamic coupling. So this sums up all of the things that I talk about. So that's all. Thank you. If you have any questions, please feel free to ask. Thank you.